All right, continuing on with notes from topic 7-8. Topic 7-8, there's a lot of information in here, and you might see one question. There was a big free response question a couple of years ago that everybody referred to as the potato problem. And it had to do with Newton's law of cooling. You'll actually be seeing it on Monday. And a lot of kids struggled with it. So, you may or may not come across this on the AP exam. They're not going to refer to it as Newton's law of cooling. And again, maybe some of you have seen this in another class. I'm not really sure, but let's take a look at the law of cooling. It states that the rate of change in the temperature of an object is proportional to the difference between the object's temperature and the temperature of the surrounding medium. Okay, so you've got T sub 0 represents the temperature of the object, and T sub E represents the temperature of the surrounding environment. So the difference between them times some constant. Okay, that's Newton's law of cooling. So let's take a look at the very first example. Again, world famous pastry chef removes a completely baked cake, places it on a cooling rack. Room temperature is a constant 60 degrees Fahrenheit. Using a cooking thermometer, he determines the cake cools from 100 degrees Fahrenheit to 90 degrees in 10 minutes. The icing that is to be used for the cake cannot be applied until the temperature reached 80 degrees. How much longer must Bernie wait to ice the cake? Okay. So let's go ahead and take a look at what we have. I'm going to use T sub C as the temperature of the cake. Okay, so again, here comes a question. How much longer will Bernie have to wait? Well, again, they're asking you a question, so giving you a derivative, that means you're going to have to find the particular solution. And you're going to have to then use that particular solution to then answer the question. Okay, so this is what we are given. The derivative of the temperature of the cake with respect to time is equal to K times the temperature of the cake minus 60 degrees. Because again, that's the environment. Okay. If you go up here, you're starting at 100 degrees. So those are the 2 points, 0, 100, and then 10 minutes later, you're at 90. So you have to be able to get the 2 points from this information. Very similar to what we did in the past. And then we have to go through the process. Okay, we take the separation of variables. Again, this is the temperature in the cake, so that's going to be here. So we need to move this to the other side by dividing. Okay, so we have a separation of variables. Then we integrate both sides. The temperature of the cake, just to make it easier, I'm just going to call that T, because now we only have I only have one temperature. So just so I don't have to write sub C, I'm just going to change that to capital T, knowing that that's the temperature of the cake. So go ahead and take the integral of both sides. This is the natural log. And this, you're integrating a constant with respect to time T. So when you integrate a constant, you get this. So this is the natural log of the absolute value of T minus 60 equals K times T plus C. So then what do? We use our first point. just like we did before, go ahead and use your first point to find your c. So when you plug in 0 in for t, lowercase t, for time, and you plug in 100 for capital T, temperature, you end up getting the natural log of the absolute value of 100 minus 60 equals k times 0 plus c. So basically c equals the natural log of 40. Same process as before. Pause the video at any time if I'm going too fast. Okay, so we go back up to this equation here, and we put our plus c in it. Again, what do we do next? We use the next point. Again, same thing as we did before. Use the second point now. So you plug in time, lowercase t, which is 10, and 90 for temperature. So you get the natural log of 30. Equals 10k plus the natural log of 40. And then I just rearranged it, got the 10k by itself, natural log of 30 minus the natural log of 40, because I'm trying to solve for k. Again, I'm just giving you some time to copy this down. If you need to pause the video, feel free. Okay, so here comes our log properties into play. When you subtract two logs, you divide the values. I used my log property, my quotient property of logarithms. Don't divide the natural logs, you divide the value 30 divided by 40 and divide both sides by 10. So there's my k. So when I put it all together, back to my original, I have the natural log of the absolute value of the temperature minus 60 equals k times t. Here's my k. I could also put the 1/10 up here if I wanted to. Times t plus my c value, which I found in my, right here. So step 1, use a point to find c. Step 2, use the other point to find k, and then here's your equation. Okay, so that's your particular solution, but it's not solved for temperature, not solved for capital T, which takes a long time to solve for capital T. You don't have to solve for capital T in order to actually answer the question, but if they ask you for a particular solution in this case, they want you to solve for T. But again, it's something that is usually multiple choice a lot of the times, and I don't know if it's worth all of the time and energy. I would do it at the end if you have time remaining on your exam. Okay, so I will go ahead and go through this. I know this is a lot. Like I said, you will only get credit if you solve for T. That's if they ask, if it's a free response, if they ask you for the particular solution. And it can be done in many ways. So in order to answer the question that they're asking, say on a multiple choice, you don't have to solve this for capital T. You could always just plug this 80 into this equation and then solve for lowercase t, or you can solve for capital T. So again, I'm going to leave this up here. Now would be a good time to probably pause so you can copy all of this down. solving for t, basically I am going to, like I did before, I'm multiplying, I'm combining this t here with this 1/10, so I can move it up to the exponent and I have the sum of two logs. When I have the sum of two logs, again, I'm going to multiply them together. That's the sum of two logs is the log of their product. And then I just use the equality property and set them equal to each other. So again, you can pause the video and copy all of that down. Plug 80 in for t. You can do that here, or you can do it here. Either way, you're going to have to solve for lowercase t, which is time. Okay, so go ahead and copy that down. Again, pause the video, and if you have any questions and can't follow, we can go over that during the next class. Okay, moving on to the last example here. This is kind of like a free response type question. Again, it's a toss up whether you'll see one or not, but I do want you to see what it would look like if you do come across this on the AP test. So it says fish are being introduced into a man-made lake. The change in the rate of fish with respect to time is directly proportional to 900 minus f. And again, for directly proportional, when you hear directly proportional, you should think of k times 90 minus f. And then they say, here's your given point, and here's your second point. So they're all pretty much the same. Write and solve the differential equation that describes the situation. So again, directly proportional is k times. Inversely proportional would be k divided by. So I use f for fish, t for time, and these are your given points. And then the process begins. We go ahead and do our separation of variables. Divide by this. You've got your change in f on the left side. You've got your change in t on the right side. Take the integral of both sides. Like always, we've got another natural log. You have to be careful with this one though, because this is 90 minus f, not f, I'm sorry, 900 minus f, not f minus 900. So this is technically a u sub problem, negative df dt right here. So you need that negative. So that's a tricky one. You need to be careful with your integrals. And then obviously you integrate a constant with respect to time, you just get kt plus c. And again, on these you only need a plus c on one side because we're actually going to calculate that c value. So process starts again. If you want to try this on your own, go ahead and pause the video and I'll go through it with you. Actually, it'd probably be a good idea for you to pause the video and try it on your own and come back. Okay, so the first thing again is use your first point. It really doesn't matter which point you use, but I just like to use the one with the 0 in it. Use your first one to find C, and when you do that, oops, that's supposed to be C equals, not K equals. Okay, so we end up getting this as our C value. So we're going to go back up to here and rewrite the equation with the C plugged in. And then your next step, again, as follows, is to use your next point to find your K. So into that equation, plug in your 600 for F, plug in your 3 for your T. Now you have to solve this for K. Again, I'm going to move the natural logs to both sides. I chose to add the ln of 500 to this side because this is the ln of 300, the ln of 500. This is bigger than this, although it really doesn't matter. The natural log of 500 minus 300. Again, using your log properties, that's the 500 divided by 300, and that's where the 5/3 came from. So there's my k value. So just like before, rewrite the equation with your c value plugged in and your k value. Again, hopefully you tried this on your own, so I'm not going too fast. Otherwise, pause the video and try to get caught up. Okay. All right, so again, if this is free response, you have to find, it says write and solve the differential equation that describes this situation. So again, this is a lot of work trying to get you, on the free response, sometimes it could be 5 points, obviously on a multiple choice. It could be 1.2 points. So just determine the situation, okay? So we have natural log, natural log, natural log. You can't use the equality property until you have one log equal to another log. So that's what I did here. I combined, I don't like this negative. I can move that up there as a -1, which I don't really want to do that. So I just moved it to the other side to make it a positive. Okay. Then I moved this to the other side by adding, and I move this one to the other side by subtracting. Now I can condense this, again, using my log properties, the log of a difference. You divide the first divided by the second, and now I have a single log equals a single log, and you can just use the equality property, which means all their parts are equal. And again, we're trying to solve for capital F. That's going to be the solution, the particular solution to this equation. So I just, I added F to both sides and I subtracted this, and there's your particular solution. If you wanted to use the negative, change the negative exponent to a positive, you can change it to 3/5. Okay? Again, a lot of work, same process, separation of variables. So then it says, find the population in another 3 years. Well, we're just going to use whatever equation you want in another 3 years. That's not t equals 3, that's t equals 6. In another 3 years, because you already know what it is at 3. If I plug 3 into here, I should probably get 600. Yep, I do. So another 3 years, t is equal to 6. So would this be a calculator problem? Maybe, maybe not. You need to know how to square a fraction. And then that would give you what? 9 over 25. 25 goes into 500 times 9. I mean, it's possible. You can do that without. I don't know if they'll make you or not, but I would assume yes. Okay. And then the last question is, find the limit of f of t, this equation right here, as t approaches infinity. So why don't you try that? Find the limit of our f of t as t approaches infinity. So as this exponent gets larger and larger and larger and larger, what is the limit of f of t? Pause the video if you don't want to know the answer right now. You are this is a geometric. You're multiplying by 3/5 times 3/5 times 3/5 times 3/5 for a very long time. And that's what you're taking the limit of. So if you are taking 3/5 of this for a very long time, this is pretty much going to be 0. It's going to approach 0. So your limit is 900. So what does that mean? That means 900 fish is the maximum number that could inhabit the lake. And that is something we're going to start referring to as the carrying capacity when we do logistic growth. Okay, so again, a lot of these problems are all the same, a lot of work, a lot of process, not really worth the points that they're going to be, but I did want to make sure that if and when you had time to do those on the actual AP exam, I would save them for the end if you see them. Okay, so that is it for section 7.8, which is the exponential models with differential equations.